you can do that. You are right. Yes. So if we run compare means and one-way ANOVA, we can put all the dependent variable here. That's true.
And then we can run the post hoc test straight away, right?
Yes.
Just one time.
Yeah.
I'm sorry, why would you do that?
مرة واحدة ليش ممكن مرة تسوي
نسويها كمان مرة واحدة.
انت قول زين لكن تسوي مرة واحدة.
لا إذا سويتها هي طريقتها نسوي تست على كل واحد روحه. نسوي تست بعد مرة عشان نشوف البوست هوك. حطيتهم كلهم بالديبندنت ورن بوست هوك تتسا.
اوكي.
نسوي كلها خلاص.
Yes, you can see here one-way ANOVA and education is not significant. Income and age are both significant. So actually we don't need to run post hoc for education. It won't show the post hoc result. Let's see the other post hoc test. Income, we can ignore the education because education there's no significance. You can see there's no stars. Okay. For income, the difference comes from group 1 and 3, the serial 1 and the serial 3, and then serial 1 between serial 1 and serial 4. Okay, so there are difference among the two. And
we should also mention the direction.
Yes, you need to tell which one is more than which. Okay, so
why is it? I'm sorry. Why is it serial 1 and 2 and 1 and 4?
They are significantly different. You can see the stars.
The stars.
Significance test. Okay,
yeah.
If it's smaller than 0.05, and it will show the significance with stars. So check all the stars.
Yeah.
Okay. There will be. Remember, there will be repetitions. So 1 and 3 are different. 1 and 4 are different. It will be repeated here. 1 and 3 are different. You only need to report in one pair. Okay. You don't need to report both.
And the interpretation or the report, how we say that, for example, serial 1 and serial 3 is different?
You can say serial 1 has less income than serial 3, and serial 1 also has less income. Those who eat serial 1 has less income
because
than
I minus J.
Yes.
Yeah.
This is I. This is J. Okay. So this is the negative. Okay. So.
In this case, serial 1 is
the income, the people's income, people who, how to say, those who eat the serial 1's income is less than those who eat the type 4 cereal. Okay, and then this is a difference of the income. And about age, you will see. Okay, so one is younger than 2, 3, and 4. Yes.
But normally, doctor, you will not ask for post-hoc, right?
It depends. Okay, it depends on the. If it's significant, then you can check where is the difference. If it's not significant, then there is no significance. And the other part you can check is the homogeneous result. It will group the similar values together in one group. For example, in the income variable, okay, you can see actually number 1, those who eat the number 1 cereal has the lowest income. Okay, so they are these 2 are in one group and these 3 are in one group, and the group 2 is has a higher income than group 1. Okay, so they are automatically group those together. For the age, you can also see group 1 is the youngest, smallest in age, and then other groups like the group 3 and 4 they are in one category, and 3 and 2 in another category. And the first one is the first one is in the first group.
Are we required to explain all of this?
In the result, like if the question is asking where is the difference, then you need to explain where is the difference, which is.
Is it enough to mention the least and the most, or we have to go to them?
sometimes the data won't show you which one is the least, which one is the most, or what is the order of the difference. You need to, for example, in this case, it's clearly showing that number 1 serial has the youngest age, okay? But you cannot draw other conclusions because they are not significantly different. You can say this one is the least in age, but for others you cannot really.
We can say that the fourth is the most.
You can. The fourth and the third, they are in one group, and they are the
So we can say
oldest. Yeah, these two are in one group. They are the oldest.
So it's enough to say that those are the least and those are the most.
Yes.
We don't need to talk about what's in the middle.
Yes.
This is also the outcome of the post hoc or the descriptive?
It's post hoc.
Post hoc.
Yeah. Yeah, most of you did the assignment quite well. You explained the differences, okay? And just write in the way that you did in the assignment. It's correct. Okay. And for what?
So this is ANOVA and chi-square. Huh?
This is ANOVA. Okay. I haven't talked about the chi-square
The other
yet.
child.
Yes. So okay. So this is one-way ANOVA. Okay, and you need to identify what is the dependent variable and what is the independent variable. The independent variable should be groups, okay, and the dependent variable should be an interval variable. Okay, so we can use ANOVA.
Can you say it again, please?
So for ANOVA test, you have independent variable, which is groups. It's a nominal variable.
Yeah.
Okay, and the groups should be 3 or more. Okay, and then for the dependent variable, it should be an interval variable. Okay, in that case, we use ANOVA.
One way.
One way or two way or two factor.
And this one is serial.
Dependent is an interval variable.
And this one is serial. The independent variable is serial. Type of serial, right?
No, it's age.
Oh, age.
Yeah, age is dependent variable. It's an interval variable, and the serials are the groups.
Okay. Yes.
Yeah,
Yes.
and the 4 groups. Okay. Okay, for that assignment, age is significant, and you can say serial 1 has younger age than other groups. Okay.
And remember, education was not significant.
Yes, education is not significant. Where is it? Education is not significant. Okay, and then income is also significant for the different serial types. And the differences are between the one who eats the first type of cereal and the one who eats the third and the fourth type of cereal. Okay. Yes.
How many questions in the exam?
What?
How many questions in the exam regarding this one?
This one, only one question. But
For
there are
calculating-
small sub-questions, like using the same data set.
Like the assignment.
Like the assignment, yes, exactly.
So it's only one question.
It's one question. One question with chi-square, one question with ANOVA, and one question with regression. The last question will be non-parametric statistics plus a regression.
Can you say that?
Because everyone was in the green.
Okay,
Three
the
questions.
first question is a chi-square test. Okay, the second question is ANOVA. The third question is regression. The last question is non-parametric tests plus one last regression.
So 4 questions.
Yes, 4 questions are for statistical analysis. And the very last, the 5th question is a case study.
Oh my god. Why don't you give us the case study as assignment number 6 and mark it out of 20 and then 10%?
Case study, one question. Only one question. It's about if there's no data. Because why I put this case study in the final exam, because earlier I want to give it to you as a case study. But unfortunately, when I purchased the case from Harvard business review, and they don't attach data for each of the case. So there's no point to
Doc,
ask you to do the data analysis.
What about frequency and these things, the histogram, the frequency and the...
No need.
Why?
These are descriptives.
Doctor, the case study, what you will ask about in the case study?
Case study, I will ask you about how you're going to use this topic to come up with a research design. For example, happiness, okay, in the workplace, or happiness in the UAE. If you want to do this research, what kind of research design? Yeah, methodology, research design. What kind of methods will you choose? Content analysis, or survey, or experiment. Okay,
You
and
just
then
name it?
yeah, you just to think about it. You just
But
plan it.
then-
You don't need to collect data. You don't need to deal with data. Just design. Just describe the plan. It's like a proposal.
So it's a verbal question.
Yeah, it's like an essay. It's like an essay question. Okay, like your article critique.
From where to study for this question, doctor?
This is the best exam will be because this is what we are studying in the proposal of our dissertation. This is what we have to focus on.
Yes. So
المشكلة we didn't have practice on this.
Doctor,
نفس اللي سويته.
from where to study for this case
the
study?
slides, the first few slides, for example.
ما هي دكتور ما هي فكرة. It's a different skill to think of.
Okay, if we go
هو
through
بيكون
the
شو آخر واحد؟
كتاب مفتوح. اللابتوب بيكون موجود.
كل شيء مفتوح بس هذا احسن شيء الديزرتيشن لما تسويه بالامتحان هذا بينفعكم.
زي بس السؤال the last question دكتور it depends on
your knowledge in the first few slides. I'm showing you now. Hold on.
will show us the question. Thank you.
So what is? So not from the first one.
هذا الاوردينال
Okay, we talk about the different levels of measurement. Okay, for example, in the research design, okay, you choose different research methods. Okay, for example, you choose a survey. Okay, and in the survey, you need to say what variables you want to measure. Okay, what is a dependent variable? What is an independent variable? For the dependent variable, how are you going to measure it? Now, for the independent variable, what kind of related factors could be used for predicting the dependent variable? Okay, say for example, happiness. Okay, and what factors will lead to the happiness? Okay, and then you can say, yeah, what kind of.
Please speak about the happiness.
No,
Can you
please,
sit
no.
down?
No, but I don't understand what happens.
Job satisfaction.
Yes,
Okay,
yes,
job
yes, this
satisfaction.
one, yes.
Okay, job
This one.
Job
It's
satisfaction.
easy that
Then happiness, yes.
Okay, job satisfaction as a dependent variable, and you need to think about what kind of independent variables could be explored. Okay,
Like
to investigate.
like
Like your research article, yes, yeah, you can borrow some ideas
if
from your
somebody wants
research
the
article.
article.
But dirham,
That
huh?
also
Ten-
helps,
ten-
right? The article
100.
critique also helps you in this case study. Okay, so then you explain like what kind of model you want for the data analysis. The regression. It's just, no. You don't need to specify the model, but you need to say like.
What does that mean? Hypothesis.
No. You need to you can come up with research questions like what factors will lead to job satisfaction. Okay, and identify some of the factors. Okay, in that case, you said you can use regression or you can use other correlation. Okay, yeah. So this is and then yeah, that's it. Okay, so you need only 5 marks for that question.
بس هي شرحت كل شيء ترى شرحت كل شيء يعني. خلاص هذا بونس كويستشن صح؟
And then, I will prepare you because I will give you a list of topics because I got all the cases from the Harvard review. So I will prepare all the articles. If you want to read that article for your reference, you can choose the topic. I will give you that article.
Okay, cool.
Yes.
How long is the test?
Okay.
2.5 hours. Yes. And yes. So shall we go ahead and continue the assignment?
Yes.
Yes.
Okay, so we finished the first question, right? The serial. The serial is done. Application. Okay. And then question 2, doctor and their specialty and age. Okay, age is the age is one of the factor, and so the dependent variable is the how much time the doctor spend on each patient. Remember that question?
Yeah.
Yes.
And then the independent variables are 2. One is the doctor's age, the other is doctor's specialty. 4 categories of specialty: OBGYN, pediatrics, internal doctor, and what is
Surgery.
Surgery.
Pediatrics, internal, and
And
OBGYN.
OBGYN, yes. So to do that analysis, because let's see, it's a 2-way ANOVA, we have randomized blocks, which is age. Okay, they blocked the age. They compare the doctors of the same age in different specialty. Right? Do you remember? Yes. So in this case, we use 2-way ANOVA. Okay, age is a randomized block. So to do this, we go to the. Let me open the data set.
But you said that you will only bring one question about ANOVA.
Yes, I'm not talking about the assignment.
Hey, assignment.
Assignment.
So for 2 ways ANOVA, we'll search for the block.
Yes,
Yeah,
if
blocks.
in the data set they said there is randomized blocks, then use 2-way ANOVA. If there's no blocks, then use 2-factor analysis. That's the difference between 2-way ANOVA and a 2-factor
If
analysis.
there are no blocks, it's two factors.
2-factor ANOVA, yes. Yeah. To do that, you need to, let's open the data set. Okay, this is 64.
And it has to explicitly mention there is randomized
Yeah,
blocks.
randomized blocks. Yes.
And
If
what's
it's
it?
not mentioned, then it's not 2-way ANOVA. Okay. If it doesn't mention any blocks, that means they are 2 factors.
By default.
Yes,
The
you can
multi blocks
just.
and 2-factor ANOVA.
What?
If there is no blocks, it means it's
2-way ANOVA. Yes.
2-way or 2-factor ANOVA.
2 factors. Yeah, if not mentioning blocks, it's a 2-factor ANOVA. Okay, so to do the 2-way ANOVA, you go to general linear model and univariate and put the dependent variable here, which is time, and then the different specialties of doctor. I put it here, and then the age, but you need to define in the model. Okay, click on the model and check build terms, and here you put main effects, and then put in these 2 factors, and click on continue and OK, and you will get the result. Okay, the result is here, ANOVA table, and you will see all the predictors are significant. The doctor in different specialty are significant. Age is also a significant predictor. So that's it. If you want to check the difference between different specialties of the doctors, you can highlight the post hoc. So once you identified there is significance among the different specialty of the doctors, you can do the post hoc. So to do the post hoc, it's the same. Okay, go to the univariate and then click on the post hoc, and this time you only put in doctors because we don't want to see the difference between the different ages of the doctors, because there are so many different ages of doctors from 30 to 65. We don't want to see what's the difference between 30 and 31, okay? So only put in doctor and then continue and you will see the result.
You didn't click to.
Yeah.
Oh, yes.
This is what I'm doing in the exam mistakes. You don't click.
Yes, thank you very much. It's here. Okay, so you can see, yeah, the five categories. Are there 5 categories of doctors?
Yeah, there's general.
Ah, general. Okay, yes. Okay. Yeah, you can see 5th, which is OBGYN doctor, spend most time with the patient, and you can make that conclusion. And others, you can see the difference. Okay.
And this is only 3.
Yeah. There are only 3 groups. Yeah. So the confirmed, the conclusion, the one conclusion is that the OBGYN doctor spend the most time with their patient. You can see from the grouping. Okay. Others you can say, yeah, that's it. Others are similar. They are in one group.
You know, the first thing I did for this question was going to test for normality first, and then I did the other steps.
For the final exam, it's not required to do normality test.
Thank you.
Yes.
Thank you very much.
Because it takes too much time. Yes. Unless it's specified, saying, yeah, if you, otherwise by default they all met the required conditions. And I think in this example, is it required? Which page is that? Page 556. 96. Can we infer that there are differences? Can we infer? Yeah, it's not required to check the normality. It's good to check the normality, but it's not required. Okay, yeah. And okay, so let's move on to the next question. The next one is.
Victor, you will go through all the questions for the assignments?
Yes,
All?
yes. You don't like that?
Not the scope, Victor.
Huh?
Let's talk about the important questions, not everything.
There's only 2 more questions left. Okay, the next one is 2-factor analysis.
Okay.
Okay.
It's important, right?
Okay.
Okay, so this one is on page 14. I forgot the question. Page 570. 570, and the question is about. Okay. So yeah, seating
Yeah, seat.
and the timing of the class. So there are 2 factors. There are 2 factors in this case, and you don't identify any blocks. There's no blocks. So in this case, it's 2-factor ANOVA, right?
Okay.
So the dependent variable is the student's response on those questions. How many responses do they have? And then the independent variables are 2: timing of the class and the seating, the different shapes of the seat. So you put in these 2 variables in the ANOVA analysis, and it will automatically have an interaction between the 2 independent variables. And you check the significance and see which ones are significant. The model is significant, okay, which means that the two predictors are important predictors. And then only the interactions between the 2 variables are significant. Okay, which means only the interactions, yeah, which means time and seat together they affect the response. Not just the time, not just the seating. Okay, 2 together they affect. Okay. The last question is a chi-square test, and it tests about the different major of the professors and what kind of approach they choose in teaching statistics class. Okay, remember that one? Yes? You like that question? Okay. So, okay, for a chi-square test, it will be better if you put the dependent variable in the column. Okay, and the independent variable in the rows. It will be easier for you to interpret, because if you see from this row, you can see the difference of how business major professors choose different approaches. Because this is what you are interested in. You want to see for different major of the professors which approach they choose. Right? If you shift, some of you, I see in your assignment, some of you put approach here and the majors of the doctors as columns. It will make interpretation of the data difficult.
Are we going to do that in the exam also, to move the data from columns to rows or something like that?
It's okay.
The result will not be changed. The significance test will not make any difference. Yeah, but it will be easier for you to interpret. You can also see it from the table. Okay, the table is the same. Okay, the dependent variable is the approach they choose. This is approach, different approaches. Okay, and the independent variable is the different major of the professors, which is the x-axis. X-axis is always the independent variable. Y is always a dependent variable. Okay, same as the here. If this one should match the table. Okay, because we got this table from the Excel. Okay, if you put the dependent variable in the column and independent variable in the rows, it will give you this table. Otherwise, it will be changed. It will be the three approaches and then 4 majors. Okay, so make sure these 2 data sets are matched to help you to interpret the data.
Both of them can be interpreted the same, even if we put them by software or manual or mathematics.
You can.
It's still meaning for me.
It is meaningful, yes, but it depends on how you interpret the result. Whether you are more interested in the approaches or you are more interested in the major. Yes. Okay, that's it. And okay, so chi-square, you will have the similar question in the exam. Okay, so to do that, just go to, I need to better open the data. And then this one is the data set.
And why, remind me again, why would we use chi-square?
Chi-square, we want to see whether the different major of the doctors will use different approaches. And the result shows that it's significant. Okay, you can see the Pearson chi-square test shows it's significant, which means different doctors prefer different approaches. And you can see from the descriptive the chart showing that the business doctors, those doctors major in business, they prefer to use software. Okay, economics doctors, they prefer to use manual, and mathematics and engineering doctors, they prefer to use maths. Okay, and other, I belong to this other category. I also prefer to use software. Okay.
Also, if the independent are nominal.
Yes.
Two nominals.
Yes.
Two
Yes.
nominals.
Two nominals.
Could be
Yes.
chi-square.
Yeah. Chi-square is always used for nominal data, both independent and dependent. Yes.
It's a good
Yeah.
indicator.
Yes.
And one-way, two-way ANOVA is between nominal variable and interval.
Yes. Exactly.
Now, how do you make it again? The kite.
The kind. Okay. Yes.
غريب بالكاي.
Go to
ما بحل شكل الشاي.
analyze. Okay, go to analyze, descriptive statistics, and choose cross tabs. Okay, here you put approaches into columns, which is a dependent variable, and degree into rows. And for statistics, you check chi-square and check the phi and the Kramer's V. Okay. The chi-square is to test the significance, okay, and the phi and the Kramer's V is to test the strength of the significance. continue. And then don't forget to check the display clustered bar charts. This will give you the chart. Yes, thanks to Isam. Credit goes to Isam. Okay, and then okay, you can check in the sales row percentages and also expected counts. Okay, check these two. It will help you to interpret the data as well. Okay, click on continue and okay, then you will have the results. Yes.
All tables should we take and put in the table?
Yes, you can copy and you can just screen shot.
And we highlight the significant.
Yes, yes,
Mean.
yes. The other way is if you want to export the table, click on the export, and it will save. You can save it into, for example, some document. Okay, and I will show you how it will look like. Let's see, I want to put it on the desktop. Save. File name. Save.
Because you have an app.
متلخبطين زيادة.
Yeah, it's there.
خلاص عارفين عندها صورة.
Yeah, it's here. So if you want to save it as a table, you can. So save it as like a Word file. Okay, like the extract. Yes, and then you can highlight. You can highlight it.
Or screenshot and just add.
You can yeah, add circles.
Okay,
Yes,
let's
fine.
go.
Whatever
Okay,
you
let's
would
go.
like. Okay.
زين بعدين.
Up to you. I just show you one the other way if you want to. Later on, for example, if you want to report those tables in your dissertation, you can use this method. Yes. What else? Okay, so we finished the assignment week 4. We'll talk about assignment week 5. The first assignment for week 5 on page 60.
And then publish nothing.
Have you finished that assignment? No. No.
Nobody started.
Somebody.
I finished only first.
Started, but just first question.
Yeah, it's a very busy week.
Yes.
Very busy week. 16139. Okay. Okay. So this data set is very interesting. So they measured the people's finger, the index finger, okay, the length of the index finger, and they said that the length of the index finger is predictive to the people's height, because some people, if you ask them to report their height, they may lie, especially on those dating websites. Okay, but if you ask them to measure their finger, it's something measurable. Okay, they will report real data. So to predict people's real height, they use the length of the index finger. And okay, so what I do is the first step is graph the relationship between the two variables. So here I put the scatter diagram with the x-axis as the finger length and the y-axis as the height, and you can see some linear relationship among the two variables. So
this is linear.
this is linear, yes. Yeah. And then we can run regression. The second question is there sufficient evidence to infer that the height and the length of index fingers are linearly related? So we run the regression to check the linearity between the two variables. And we put the height as the dependent variable and the index finger length as the independent variable. And the model shows there is a significance, okay? And it explains R squared is 0.327, which means 33% of the variance can be explained. And then, yeah, you check the coefficient of the index finger length. here again it's significant, which means the index finger is a good predictor of people's height. Okay? Yeah.
I run a regression correlation.
You can run the same result. It's the same coefficient.
Because we have one here, one of each.
The R should be same. The R should be same.
Yeah.
Okay,
Yes.
but if you run regression, if you run correlation, you cannot say who predicts who. Maybe you are tall, the height can predict the finger length.
So now
If you can-
which one is that?
So it's better to use a regression.
In this regression, which one did you put as dependent?
I put the height as a dependent, index finger as independent.
But if you put it the other way around,
It will put, if you put it will also.
so you cannot tell which is.
But then it depends again on the interest of the questions. Which one is?
I mean, you cannot tell which is the reason of which, because you can just change the dependent and independent in the regression model.
True. Yes.
And you
In
can
this
say
one,
whatever
true.
you want.
Yes. Yeah. In this case, yes. The equation will be the same. Only the negative and the positive will be changed.
I think it depends on the question itself.
Yes,
The question is asking
If
you
they
to-
are interested in the height, in the prediction of the height, then the index finger should be the
The
independent
independent.
variable. Yes.
Okay.
Yeah. In this case, because they are really interested in the people's height, and they said that the height is not a correct number. People could fake their height. Okay. That's why they want to check people's index finger, and the index fingers are the real data. Okay. And what we can use for this data is that the next question is about the prediction. If we know someone's finger length and we want to predict their height, we can use this regression model. So in this case, we will use the prediction. And
You can apply the formula, the equation.
you can, but you can only get the point estimation. We want to get a more accurate range of the
Confidence.
confidence interval.
Lower and upper.
Lower and upper.
Yes. So to do that, you need to let me open that data set.
This is C,
This is
part C.
This is question C. Yes.
Mhm.
Question C. Open the data set. File. Okay, so now we have, I will delete this. Okay, so now in the question C, it says predict with 95% confidence the height of someone whose index finger is 6.5 centimeter long. So here the index finger is 6.50 centimeter long, and we want to know the height of the people. Okay, but it will come like a range. So what we do is we go to analyze and regression and click on the linear, and we put in the height as a dependent variable and index finger as an independent variable. And here in the save,
Mean individual.
yes, we check the prediction intervals, mean and individual. The confidence level interval is 95%. So click on continue and okay, you will get the range. Okay, so the mean interval is smaller than the individual interval. We always use this one, okay, to be more accurate in this using this range. Use the mean. In some questions, they will say what is a range of the mean interval, what is a range of individual interval. But if it doesn't mention which one to look at, we always check the smaller mean.
Sorry, I didn't understand this because I used the last one.
The last one is the individual interval. This one is based on the mean of the height. This one is based on the individual height. So individual height, you can see the range is bigger than the mean range. The mean range gives you more smaller and a narrowed range, and it's more accurate.
So So we're always
prediction.
going to that.
Yeah, if it doesn't say in the question whether it's individual or mean, you always use this one. It's more accurate
Okay.
for prediction.
Okay.
Okay.
And you take a screenshot?
You can report the range 164.45 between this number and this number. Just copy the two numbers and say this is a range. Okay. Yes. So that's the first question, and the second one. Where is it? The second one. Yeah. Yes, I put it here. So the steps. Okay, I will send you this document. Oh no, I shouldn't.
That's
Your
just
assignment. Okay. But you remember the steps, right? Check the prediction intervals and check both mean and individual, and you will get the range. And then the second question is 708. By the way, they are all on the slides. If you forgot the steps, it's available on the slides. The steps and which function to choose. This one is about. Okay, so your age. Okay, so your lifespan is dependent on your parents' age and your grandparents' age. Remember that question? Yes.
Yeah.
Smoking is another variable. Okay. So, so the first question is perform a multiple regression analysis on these data. Is the model valid? Okay. So we performed the regression analysis and put the age as the dependent variable, and then the age of the parents and the grandparents as independent variable. The model shows it's significant, okay? So ANOVA test in the regression shows you the validity of the model, whether this model is valid or not, okay? You need to report the F data and the F value and the significance.
You should report the F value also?
Uh-huh.
You should report the
Yes,
F value?
F. Yeah,
You should.
yes, you should.
Okay.
F equals 67.967. P value is smaller than 0.001. It's significant. Uh-huh. Yes?
They have different.
You have different results?
Yeah.
I don't know.
Sure.
Maybe you added smoking. Then, okay, so
I'm sorry, what's the significance of the F? Why do we include it? What does it mean?
it means the model is valid.
That's it?
Yes.
Well, I thought the P value is derived from the F value. I remember last time I asked you.
Yes,
because
F
it's just
value
calculated.
is to test the model's significance. It's a probability test.
How do you know this is significant? 67.967.
No, this one is
Yeah,
significant.
okay, but what about
yes.
the F?
The value you have, you can ignore it. You can ignore the size of the value, the magnitude of the value. But you need to just report the data
report,
here.
okay.
Yeah, just report it and saying this is significant. Okay. Okay, where is, okay then, okay, so this next question, determine the 95, okay, interpret this, the next question is interpret the test of the coefficients. So we check the coefficients of all these four predictors: mother's age, father's age, grandmother's age, and the grandfather's age. And then we find that now, actually only your parents' age matters. Okay, they are significant predictors of your age, but not your grandparents. Okay, so you can explain. And both beta, the coefficient, are positive, which means the longer your parents lived, the longer you will lived. Okay.
This is the beta. This is the model actually.
This is the model. Yeah, this is the equation. You can put in this in the equation.
Because after that we solve by the model actually.
Yes, yeah, you can use you can put those coefficients in the model. And more interestingly, you can see mother has more weight than father. Okay, if you if your mother lives longer, then means you will live longer. And I mean your mother puts more weight in the longevity of your life. Okay. And okay, so the next question, determine the 95% interval of the longevity of a man whose parents lived to the age of 70. So in this case, the same steps, okay, but you need to put.
But the first and second question, can you show us how did you get the?
The first and the second question, sure.